Hello, Geometry. This is Chapter 8, the first lesson in Chapter 8. Similar polygons. Get that off there. There we go. So the essential question here is, how are polygons similar? Check the focus here. A little bit better. So, how are similar polygons related? Now, remember, to be similar, basically what you have to have is the same shape. That's not writing very well. Same shape, different sizes. Okay, that can be referred to as similar shapes. So squares can be similar because it's the same shape, but it's a different size. Back when we did a unit on transformations, a similar transformation would be a dilation. Okay, remember reflections, rotations, translations, they were all things that were rigid transformations, so they kept the same size and set shape. That led to congruency. They're called congruence transformations. A similar transformation would be a dilation, when you're changing the size of what you have here. So we can do some transformations on some of our graphing tools, either GeoGebra or Desmos. Let's just draw a triangle here. Okay, so I have a triangle. Let's move it over here a little bit. And what I want to do is I want to transform it. I want to do a dilation. So a dilation creates similar things. So it says choose a point. So let's dilate it with that point right there. Scale factor. You see the scale factor right here. If this is greater than 1, you're going to get a bigger object. If it's less than 1, you're going to get a smaller object. So I want a smaller one. So I'm going to say 0.5. So between 0 and 1. Okay, so select some objects to apply this transformation. So I want to apply it to this triangle. And apply. So you notice each side length was reduced by a half in relationship to this point right here. Now I can kind of drag that out, and you can kind of see that happening. Everything is in relationship to this point. I would draw a segment connecting this point to my original points. You'd see they all line up with the points in the similar figure right there. Okay, no matter where I move this, they're going to stay in relationship to each other. It's the same shape, but it's different sizes, even if I move these points here. Okay, we can add some other transformations here. Let's apply this to here. There's another half there. And let's get 1 in the 4th here. Let's do another dilation. I want this as my center again. I want 3/4 of the way, so 0.75 applied to that one. You got one right there. Like Bob Ross, a happy little triangle family. Okay, so you can kind of make your own can-can line. Anyway, having too much fun here. Okay, so all of those would be similar shapes. You can go one that is bigger than. Let's do one more. Dilation, we're going to do it around that point. And we'll go 2. So that creates that bigger one. Okay, so going a scale factor greater than 1 creates something bigger. A scale factor between 0 and 1 creates something smaller. If I would go a negative, let's see if it'll let me. See how that flips it upside down, actually. Rotates it 180 degrees and flips it upside down. So those would all be similar shapes. You can definitely get on here and play around with this, create similar shapes, create some cool things. This does fun things with the perspective. If you're in art class dealing with the perspective. Okay, so some of the vocabulary here. Compare the corresponding angles of triangle A prime, B prime, C prime. Remember, the name there is when you have the primes. That is referred to as a prime. This is the image. It's the new one. This would be referred to as the pre-image, and it's the old one, or you can think of it as the original. Okay? So if I would have a similarity transformation, and I draw this one in here, this could be A prime, B prime, C prime. Okay, scale of 1/2. Same shape, different sizes. Okay, let's get moving. There's some vocabulary. Don't want to get too long for you. So, similar figures, page 223. Similar figures, two shapes whose angles, I'm going to put whose corresponding angles are all congruent and corresponding sides are proportional. Remember, proportional is basically two fractions that equal each other. So two shapes whose corresponding angles are all congruent, corresponding sides are proportional. So same shape, different sizes. Proportional would be like 1 over 2 equals 2 over 4. That would be proportional. Two fractions that equal each other. Similarity transformation, that is a dilation. Okay? So the angles stay the same. And the sides are multiplied by a scale factor. So dilation, angles stay the same, sides are multiplied by a scale factor. So corresponding parts, remember that is the congruent angles paired together, and the proportional sides paired together. So this chapter closely follows some of the things that we learned when we were dealing with corresponding parts of congruent triangles. Okay? So congruent angles paired together, proportional sides paired together. So corresponding parts of similar polygons. Okay, so this is our similarity transformation. So we're starting with triangle ABC. I want you to notice how the sides are named in lowercase letters opposite the opposite angle. So side A is opposite angle A, but it's lowercase. Side B is opposite angle B, but it's lowercase. C is opposite C. A similarity transformation, that could be a dilation. Okay? So the angles have stayed the same, but K is what we use for our scale factor. So K is our scale factor, and it's always going to be the image, which is the new, over the pre-image, which is the old. That's how you always find your scale factor. You have to take one of your image sides divided by your pre-image sides. So it's always the new length divided by the old length. Okay, so those are your, how you find the scale factor here, which is K. So K times A gives us the new length. K times C and K times B. So here's how you write your corresponding angles. Angle A, remember to use the congruent symbol. Okay, angle A is congruent to angle D. You could say measure of angle A, then you would say equals the measure of angle D. When you're dealing with the measures, you're dealing with a number, so it's equal. When you're dealing with an angle, you're dealing with an object, so they're congruent. Objects are congruent, angles are equal, measures are equal. Okay, the ratios of the corresponding side lengths, so they said DE, right here, divided by AB, so those are your corresponding side lengths. Again, DE is the new length. So it's the new over the old, or the image over the pre-image, or the new one over the original. Okay, so DE over AB has to equal EF over BC, which has to equal FD over CA. Okay. Now, if K, your scale factor, is greater than 1, you're going to have an enlargement. and that means your shape gets bigger. So if k is greater than 1, you have an enlargement, the shape gets bigger. If 0 is less than k, which is less than 1, you have a reduction, which means you're going to have a smaller shape. We saw that on Desmos there earlier on. Okay? So flip it over here. Corresponding lengths in similar polygons. So if scoot up here. If two polygons are similar, then the ratio of any, then the ratio of any two corresponding lengths in the polygons is equal to the scale factor of the similar polygons. Okay? So that's just saying that if two shapes are similar, every set of corresponding sides must have the same scale factor. So every set of corresponding sides must have the same scale factor. Okay, the symbol for similar is just the top part of congruent sign. Okay, just the top part of the congruent sign. We'll see that right here in Theorem 8.1. You see that symbol right there? That means is similar to. So, and if it's similar to, you know your corresponding angles are congruent, and every set of corresponding sides has to be proportional. Okay, perimeters of similar polygons. We've seen these in a few questions popping up here and there through our assignment. Here's our proof. If two polygons are similar, then the ratio of their perimeters is equal to the ratios of their corresponding side lengths. So this just says your perimeter has to equal your corresponding sides. So these are the corresponding sides here, and it has to equal the ratio of the perimeter. So if they give us that KLMN is similar to PQRS, which is they're telling us, and let's say this perimeter right here is 24 and this equals 3. Okay? So this is how we're going to work this. If this equals 4 and we know these are similars, we're going to get used to setting up proportions. We're going to set up proportions. So we want to know, what is this perimeter here? We know these two shapes are similar. The scale factor, the sides are 3 to 4. So setting up a proportion is going to be a very important thing of what we're doing with this. So what we do is we take something that we know. We know 3 is 24. So this has a side length 3 over 24. So side length of 3 with a perimeter of 24. That has to equal a side length of 4 with a perimeter of what? Okay, so that becomes our x right there. So 3 is to 24 as 4 is to what? So we can cross multiply. So 3x equals 4 times 24. 3x equals 96. Divide by 3 and you get 32. That means that perimeter is 32. Now I want you to think, is there another way you could have set up that proportion? Well, of course, there's going to be several ways. We could switch these around. I could go 24 over 3 equals x over 4. I could do it that way. You can set up a proportion with your scale factor between the sides. I could go 3 is to 4 as 24 is to x. You can set them up that way. You can solve that. 3 is to 4 as 24 is to x. So my final question here is, if I'm starting here, if this is my pre-image and this is my image, what is my scale factor? Okay. So your scale factor, remember, is your image over your pre-image. So it would just be 4 over 3. That is what you refer to as your scale factor. You take what you ended up with, divide it by what you started with. So that deals with the perimeters of similar polygons. The perimeters have the same scale factor as the sides. Now 8.2 deals with the areas of similar polygons. The areas are the square of the scale factor. Okay? The square of the scale factor. So the area of one equals the area of other. So let's take the same setup here. So let's say this is 3 and 4. And now they want to say this area is, let's go 18. No, pick the number. Completely pick. And we want to know, what is this area? So we can't use the same ratio as what we had before. So it's the square of the ratio of the sides. So use the square of the scale factor. So our scale factor we know is 4 over 3. We're starting with this one. So 4 over 3. So since I have area, I have to say 4 squared over 3 squared equals, now 4 came from this one. I don't have that. So x over 18. Again, there's different ways to set this up there, but this 4 and the 3, that is where the squares have to be. So on this one, you use squares, and on this side, the area numbers, this is the side length number, so on the side length numbers, we're going to use the squares on there. On the area, we don't use squares. Okay, so let's solve this up. We got 16 over 9 equals x over 18. 9 times 2 is 18, so 16 times 2, x would have to be 32. Oh, how about them apples? So area would be 32 square units. Okay, again, you can cross multiply, take 16 times 18 divided by 9. Use the z method, if you know that from Mrs. Sattler. Okay. Let's just take a set of triangles. Or not triangle, the rectangle. So let's say this is 2, and the area is, let's use a easy number, 16. Okay, so here's another rectangle. Let's say this is 4, and we want to find out what the area is. Okay, so we can say our scale factor here is 2. So we can take 2 over 4. We can do it this way as well. We can say 2 over 4 equals 16 over x, but remember, these are the sides, these are areas, so I have to say 2 squared over 4 squared. Now keep in mind, our scale factor would be 4 over 2, which is 2. And you can use it that way. You can look at your numbers and just set a proportion as well. So you get 4 over 16 equals 16 over x. Cross multiply or look at your relationships. 4 times what is 16? Well, 4 times 4, so 16 times 4 would give us 64 there. Or you can cross multiply 4x equals 256, and you get x equals 64. The area of this one is 64. So when you take the length, side length, times 2, you have to take the area times 4. 16 times 4, 2 squared. Okay, in exercise 1 and 2, the polygons are similar. That means congruent sides and proportional lengths. Sorry, congruent angles and proportional sides. Find the value of x. So it looks like you need corresponding sides. So it looks like the 2 corresponds with the 3 and the x corresponds with the 7. So we can set this up. 2 over 3 equals, now I started with 2, I went to 3, I got to come back to the x over 7. Cross multiply, 14 equals 3x, so you get x equals, we're just going to call it 14 thirds. 14 thirds. You can set it up another way as well. I could say 2 over, there we go, 2 over x equals 3 over 7. Okay, you solve that, you're going to get 14 equals 3x, so x equals 14 thirds. Same thing over there, you can see it. Okay, a couple ways to solve it, a couple incorrect ways to solve it as well. It would not be okay to say 2 over 3 equals 7 over x. That's kind of a common one that happens No. 2 over 3 does not equal 7 over x. Okay? 2 over x does not equal 7 over 3. Those are not your corresponding sides. So those are ways that it would be incorrect to do it. So here, 8, find out where does the 8 correspond to. This looks like a sort of rotation, so the 8 corresponds to the 20. So I would say 8 over 20 equals, okay, x over, x looks like it matches up with the 25. So 8 over 20 equals x over 25. So multiply that over, you get 200 over 20 equals x, and you get x equals 10. Okay, proportions, cross multiply, solve. Honestly, a little bit with the middle school with that. Okay, find the scale factor, last page. Okay, find the scale factor from A, B, C, D, E to K, L, M, N, P. Okay, so this direction you're going is very important. This is your image in this case. This is your pre-image, and this is your image. So you have to take the image side divided by your pre-image side. So let's find out what we have. We have a 3. So we're going from this one to this one. There's a 3 over 2. So that would be your image, which is 3, over your pre-image, which is 2. So it would be 3 over 2, or you could say 1.5. Okay, so you take every side times 1.5, and you're going to get these sides. Find the scale factor from K, L, M, N, P to A, B, C, D, E. So now we're going backwards here. It's going to be the reciprocal. Okay, because now your pre-image is this one. So when you do your image is from the second one here, which is 2, over 3, which is going to be your pre-image. So you get 2/3 as that scale factor. Notice it's getting smaller, so your scale factor has to be between 0 and 1. On number 3, it's getting bigger, so it has to be bigger than 1. Find the values of x, y, and z. Okay, x is a side, y is a side, z is an angle. Well, we like angles. Angles are going to be congruent. So z corresponds with that one, so z has to be 45. That's easy. X. Okay, so x corresponds with the 1. So I could say x over 1 equals 3 over 2. So cross multiply, we get 2x equals 3, and x equals 1.5. 3 halves, 1.5. Okay, I usually just set up these proportions each time. You can use your scale factor if you want. Okay, so there's your x, the y. Y corresponds to 3 root 2. So y over 3 root 2 equals 3 over 2. Now, how you solve this with the square root here is when you take this up here to multiply, you got to take that times 3 root 2. The 3's multiply and the root 2 stays. So what you're going to get is y equals 9 root 2 over 2. You do not simplify the 2's because one is inside the square root and one is outside. Okay, so that would be your answer for y, 9 root 2 over 2. You can use a decimal, a calculator, get your decimal for that one. Find the perimeter of each polygon. Okay, so this one's easy. A, B, C, D, E is going to be 2 plus 1 plus 1 plus 2 plus 3 root 2. So how that's written is we're going to put these 4 numbers together, 2, 4, 6, and we write it as 6 plus 3 root 2. Okay, that square root stays just like that. 6 plus 3 root 2, you could use a calculator to get the decimal for that, but this is the exact answer. The 6 and 3 you cannot add together. Okay, so our scale factor here, this one, we know this is 9 root 2 over 2, and we know these are 1.5, 1.5. Okay, they're also half of those. So here, for K, L, M, N, P, that would be 3 plus 3 plus 3, 3, 6, 9, 9 plus 9 root 2 over 2. Okay. So if you would take these numbers times 1.5, you're going to get these numbers. 9 over 2 is 4.5. Find the ratio of the perimeters of A, B, C, D, E to K, L, M, N, and P. Now the ratio of the perimeter should still be the same as the scale factor. So let's go back and look. A, B, C, D, E to K, L, M, and P. Scale factor would be 3/2 or 1.5. So if you would have taken these numbers, if you take 1.5 times 6 plus 3 root 2, distribute that in, 1.5 times 6 is 9. 1.5 times 3 is 4.5, so that would be 4.5 root 2, which is the same thing we have here. 9 plus 9 over 2 is 4.5 root 2. Find the ratio of the areas of A, B, C, D, E. Okay, the areas, you have to take the scale factor and then square it. So our scale factor is 3 over 2. So if I square that, that would be 3 squared over 2 squared, which is 9 over 4. Okay, so if we had the area of the first one, we could use this ratio right here to find the area of the second one. So let's say the area of the first one is 10. Okay, we could say 9 over 4 equals, well, the 10 would have to go with the 4 because the 10 is on the smaller side, so it has to go with the smaller number. And then we're looking for the area of the second one. So 9 over 4 equals x over 10. Cross multiply, you get 90 equals 4x. So x would equal 22.5. So that'd make the area of the second one 22.5. So areas use the square of the scale factor, perimeters use the scale factor. There's a lot of different applications. I'm not going to be able to prepare you for every question, but if something comes up in your assignment tomorrow, feel free to ask, and we'll go over anything that still needs some clarification. So good work. We'll see you in class tomorrow.